So today we're going to finish up section 1.1. So anybody remember what two operations we used yesterday to solve equations? What were those two operations? Shannon?
Addition and subtraction.
Yeah, we used addition and subtraction. So today we're going to look at two other operations, okay, which is in the title, multiplication and division. So those are the two things we're going to use. We're still going to be solving equations that are just one step. Okay, we're not into equations where you have to do multiple steps yet. Okay, tomorrow we'll start that. All right, anybody have a guess what this property is? So we said yesterday the addition property of equality allows you to add the same number to both sides. Subtraction property of equality allows you to subtract the same number from both sides. How about the multiplication property of equality? What do you think that allows you to do? Emily?
Do these same problems but with multiplication?
Yeah, so multiplying the same number on each side of an equation.
So guys, remember yesterday when we had like addition in a problem? What did we use to solve it? If that addition was like x plus 9 equals 3. What operation did we have to use? Anybody remember? Yeah, we used subtraction. We used the opposite thing. So if it's the multiplication property, all right, what operation do you think is going to be in the problem? So you're going to use multiplication to solve. What operation do you think is going to be in the problem? Division, right? Remember, what the name of the equality is, we're going to be doing the opposite thing. All right, so it's multiplication, so we're going to use multiplication to solve problems with division.
Right, so that property, again, it just says you can multiply both sides of an equation by the same number, except there's one number you were never allowed to multiply both sides of an equation by. Does anybody know what number that is? Yeah?
0.
Yeah, 0. Because if you had an equation like, let's say, x divided by 2 equals 10, and you said, oh, I'm going to multiply both sides by 0. What happens when you multiply something by 0? What do you get? 0. So now you just wiped everything out that's on the left. And what's 10 times 0? Now you wiped everything out that's on the right. You have nothing left. Okay, so you never want to multiply by 0 because it destroys everything. Okay, same thing with division. You never want to divide by 0 either.
So guys, Mr. Hager just gave an example here of when we've used the multiplication property of equality. Can somebody give me another one? Another example. You can make up any letters, numbers you want. Can someone give me another example of an equation where we've used the multiplication property of equality? Anybody know? Anybody want to give it a shot? Again, if I'm going to use division, if I'm going to use multiplication, what might I have in the problem? What type of a number? Let's start off with this. What am I going to have? Liam? Fraction. Give me a fraction. 1 over 3. Liam, for it to be an equation, what needs to be attached? I'm going to put an equal sign. I'm going to leave a little space. I'm going to put an equal sign. What do you want to put on the other side? You can put any number you want. Any number you want. 2. Is this, right now, Vanessa, what are you going to say?
You need to put
Some kind of variable. What about, am I going to put the variable with the 1 over 3 or the 2?
1 over 3.
I want to put it with the 1 over 3. That's an example of a equation where you're going to use multiplication. Right? That's a perfect example. Right? Because what every fraction is really division. Right? If we wanted to make this a decimal, we do 1 divided by 3. So every fraction we deal with now, in January, in May, all right, it's still division. It's still dividing. So that's a perfect example what an equation is going to look like when we're going to use multiplication.
All right, so here's an example of an equation. Okay, it says 2x equals 6, and I want to double each side. Ashley, can you tell me what I'd have on the left if I double that? Yeah, we'll go with Ashley A. 4x. And how about Ashley B, if I doubled what's on the right? Doubled it, 6 times 2?
12.
12.
I meant 6 times double 6.
So if you double 2x, you get 4x. Double 6, you get 12. What's the answer to this top equation? 2 times what gives me 6? Yeah? 3. And 4 times what gives me 12? Yep, 3. So these are the exact same equation. Right? Multiplying each side of an equation by a number doesn't change the answer that you get. And that's important. Because if it did change the answer, then we wouldn't be allowed to do it. Okay? We can't mess up the original problem. So everyone see how multiplying each side by the same number did not change the answer that you get for the equation. Okay. So sometimes, and Mr. Roy just showed us an example, the number in front, okay, of the variable, the coefficient, is a fraction. Does anybody know how you deal with an equation like this one? You multiply each side by something. Does anybody know what it's called? Or if you had something like this. I want to get this 3 and this 4 on the other side, both at the same time. So there's something I can multiply by here and here that'll cancel the 3 and the 4 at the same time. Do you know? You have a guess? No, not 12. It has to do with the 3/4.
Remember, just like we did, we want to get rid of that, what's attached to the x.
Josh? Yeah.
Yeah.
Very good, the reciprocal. Okay, so if you have a fraction, okay, in front of the letter, you multiply each side by the reciprocal. All right, and we're going to talk a little bit about what a reciprocal is, and we'll give you guys some examples. All right? So basically, a reciprocal is when you just take your fraction and you flip it. That's it. All right, so I have a fraction here, 5/2. Anyone think they could tell me what the reciprocal would be of 5/2? Yeah, Ashley? 2/5. So if I had a problem like this, just make up a number, and I wanted to get x by itself, I'm going to use not 5/2, but I'm going to do something with the reciprocal, which is 2/5. Okay? And we'll try one like that, but not yet. How about -3/4? What's the reciprocal of -3/4? Liam? Good. Okay, remember when it's negative, flipping it doesn't change whether it's negative or positive. If it's negative, keep it negative.
And you're not making it the opposite. You're just flipping the fraction. You're not making it the opposite number.
How about 2/a? What would be the reciprocal of 2/a? Brett? A/2. Doesn't matter if it's a letter or a number. You just flip it. And what's the reciprocal of b/c? Kyle? C/b. Yes, that's the point of the reciprocal. You just flip it. Okay, so we still haven't solved an equation yet using this idea, but that's the first step, just understanding what a reciprocal is. Okay, any questions on that? All right, so the first one Mr. Roy is going to go through doesn't have a reciprocal. The next one will. So if you wait, when are we using that idea of a reciprocal? Hold off for example 1b.
And we're gonna do, just like we did yesterday, guys, we're gonna do example 1a. all right, right next to it, you'll see the space for it. So, same thing as yesterday, we're gonna find the number with the variable. And when we're dealing with today, it could be a fraction. So for that first bullet, we wanna find the number with the variable, and that number with the variable, when we're dealing with this stuff today, could be a fraction. So for that first step, for that first bullet, you want to find the number with the variable. Now, a couple of things are going to happen. All right, guys, let me see. For that next bullet, do me a favor, guys, for that next bullet, just skip it and write it on the next little thing that looks like this. So you're going to multiply both sides of the equal sign by the denominator, or multiply both sides of the equal sign by reciprocal. There's a fraction attached. You got two little things. After that second bullet, you got two little things right there, so that's where you want to write this stuff in. Go on to the next one. We're going to simplify both sides of the equal sign. Then the last thing, if it asks us to check it, we'll check it if we need to. So when I look at that first example, example 1A, you guys have some space. You don't have to do this. I'm just going to write it up here for myself, guys. So when I look at this, I got x over 4 equals negative 7. Am I looking at situation 1, where I'm going to multiply both sides of the equal sign by the denominator? Or am I looking at the second situation, where I'm going to multiply both sides by the reciprocal? What situation am I looking at? Can someone tell me? Shannon?
Multiply by the denominator.
Multiply by the denominator. How come I don't have situation 2, Shannon?
Because you have a variable on the top and bottom.
Yeah, I really, for this one, I really don't have a numerator. I don't have a number on the top. All right, so I'm just going to multiply both sides by the denominator. Remember, numerator is the number on the top, denominator is the number on the bottom. I always remember denominator down, bottom, it starts with D. That's how I remember it. So, I'm looking at situation 1. I'm going to multiply both sides by the denominator. All right, so, Derek, what am I going to multiply both sides by?
The denominator,
Which is?
the number on the bottom,
And for this example, what is it?
4.
4. I'm going to multiply both sides by 4. All right. Here's my equal sign. Hannah, on this left-hand side over here, what's left? I'll give you a hint. X, right? That's why I'm multiplying by the reciprocal. That's why I'm multiplying by the denominator. Not because I like multiplying by fractions and doing that kind of stuff. It's gonna get rid of, it's gonna make your life a lot easier because you're not dealing with any fractions now, right? In algebra, we always want to try to get rid of the fractions so we can get the whole numbers, because those are a lot easier to deal with. So I'm gonna get rid of that's gonna cancel out the 4s. Now on the other side, all right, Emma, is my answer gonna be positive or negative? On the other side, on the right-hand side. I got -7 times a positive 4. Negative, right? Remember our rules we talked about last week? Positive times a negative is a negative. Ashley A, what's that number gonna be? Negative what? Negative 28. That's it. I simplified. Now I'm gonna check it. So I did this. It was this first situation. I multiplied by the denominator. All right. I simplified both sides by multiplying 4. Now I'm gonna check. So when I check it, what is that problem gonna look like? What's it gonna read like? Anybody think they might know? Marissa? -28 over 4 equals -7. So all Marissa did was she took what she got for her answer, -28, plugged it in for x, aka evaluating. So we do that. Is my answer here, Marissa, is it going to be negative? So I'm in good shape with that. And negative, you already know it's negative. I do 24 divided by 4. 28 divided by 4, I get 7. -7, -7. It checks out. And again, we're not going to make you guys check every single one. That just shows how it works. So in that case, we only have to multiply. Again, and there'll be a couple on the test. There'll be a couple on the homework where your numerator is going to be a variable. Right, so you only have to multiply by one thing. Now, a little bit different. We're just going to solve this one. So, Sabrina, what do you think? 3/2. All right, so I'm going to do 3/2. Sabrina, what math operation am I going to use? Multiplication, because it's a division problem. So I'll multiply that. Am I going to multiply on the other side? Yeah. Perfect. I'm going to multiply by 3/2 on the other side. Sabrina, why did I multiply by 3/2 on this side? Has a variable with it. I agree. And when I multiply 3/2 times 2/3, what's going to happen? Just the variable, right? We did that so we get rid of we did that so we can get rid of the fraction. We don't want to deal with that. We get y. Whoa. What about this other side? Josh. Yeah, any whole number has one underneath. We just don't write it every time. We can make, and this is really important when we start getting the graphing and stuff like that. You have to know that any whole number, even though the 1's not written there, is over 1. We just don't write it every time. We assume it. Just like if there's no number, no sign to the left of a number, we know it's positive. Every number could be written to the first power. We don't do that. Just how it is. We know it's to the first power. We don't write it every time. So I can do that. I can put this over 1 like Josh just said. Now, you can do these a couple different ways. One way people might do it is, you might say, okay, I'm going to cross cancel this, make this 1, make that 3, do it that way. All right? Me, I don't, doing this kind of stuff, I usually don't. If you do it that way, you're not wrong. Anybody know another way I can do it? Josh? Yeah, multiply straight across. Like this, like this. So I'm going to do 6 times 3 first, Josh. What do you get? 18 over what? 2. When you do it this way, though, you have to make sure you simplify. So this is 18 over 2. But I said earlier, every fraction is really a what? Anybody know? It's got that line there. What do you think, Josh? Yeah, every fraction is really a division problem. All right? So Josh, what does this say?
18 divided by 2.
What do you get when you do that? You could have, if you did do it the other way, I'm just going to show you guys up here. If you did it this way, 1 goes into 1 once, 2 goes into 2 one time, 2 goes into 6 3 times, then I'm in the same situation. I'm going to multiply straight across. 3 times 3 is 9 over 1. 9 over 1 is really 9. You could do it either way. Some people might have learned to do it this way. Some people might have learned to do it this way. This is going to eliminate a step. You don't have to simplify at the end, but this way is not wrong either. Or you could put it in your calculator. You could put 6 times, there's like a little ABC button that kind of looks like this on your calculator. I think it's like A, kind of looks like that. If you hit that button, you'll get it. I showed a lot of kids. In my years of teaching, I've showed kids this button. It's a magical button. Because me, I don't like to deal with fractions. All right, so when I get to do when I have to do them, a lot of times I'll just use the calculator. I'll use this button. All right, so that's another way to do it. Again, learn that magical button. Love that magical button. It helps.
All right, so we studied the addition property, subtraction, multiplication. What do you think our last one is? Division. All right, and the division property of equality allows us to divide both sides of an equation by the same number. Okay? Only number we can't use is 0. Okay, so we are allowed to divide both sides of an equation by the same number. All right, so let's try this one. Okay, I've got 18 equals, and who can pronounce what's on the other side here? How do you pronounce what's going on over there? 3 times x. So whenever we want to get rid of something, we use the opposite operation. What's the opposite of multiplication? Yeah, that's the property I just mentioned. Anyone think they could tell me what I would divide by to get rid of the 3 next to the x? Yeah, Vanessa? 3. Divide by 3. Divide by 3. What's left on the right-hand side, Vanessa? Just x. And go ahead, Marissa, what's on the left-hand side? 6. 18 divided by 3 is 6. And we could check it. 18 equals, what would I write here when I check it? Shannon?
6.
Just 6?
Oh, 6x. Or no, not 6x. Never mind.
Start with 3.
3 times 6.
Yeah, 3 times 6. So that's the question. Does 3 times what I think the answer is give me 18? Yeah, 3 times 6 is 18. That's correct. All right, how about this one? 5x equals 40. Well, Derek, what am I going to do here? What operation do you think I'm going to use to solve this one?
Division.
Yeah, we're going to use division. And you want to tell me what I need to divide by to get x by itself?
5.
Yeah, by 5. Good. Okay. When I do that, Natalie, what's on the left-hand side now? Just x? And how about on the right? Just 8. And that one, we're just going to solve it.
Hey guys, most of the time, what we're doing right now, that's like almost always, I want to say 95% of the time, that's how you solve an equation. Equations we do from now till the end of the year, whether it's a word problem, whether it's whatever, that's always your last step. Most of the time, you're going to divide by the number attached to the variable.
Okay, so any questions on what Mr. Roy just said, solving equations where there's a number attached to that variable? All right. All right, so the last 2 problems we're going to look at are word problems. Okay, and one of them is going to have the word of in it. Does anybody know what that means in math, the word of? said is means equals. We have some other words that are important, but Ashley? Yeah, of is often used to mean multiply or multiplication. For example, if I said 2/3 of 12, right? And I said, what is 2/3 of 12? It means, on your calculator, do 2/3 times 12. All right? So if I gave you this one, okay, I'm not sure, I don't think you guys have a spot to write this. Okay? But if I said to you, what's 3/2 of 12? How would I write that in math without the word of? I want to write 3/2 of 12. Liam?
3 over 2 times 12.
Yeah, it means 3/2 times 12. And then what about the word is? What does that mean? Josh? Equals. And the last thing that's important here is number. Well, we don't know the number, so what do I do when I don't know something in math? How do I represent it? Yeah. With a variable, sure. What do you want to use? Sure, use n for number. And now to get the answer, all I have to do is multiply these together, which this time I'll do on my calculator. Okay, I don't have the fraction button, so I have to type it in a little differently. So 3/2 times 12 gives me 18. All right, so we'll probably see a lot of word problems that have the word of, and we just need to know it means multiply.
What, a lot of they'll see times.
Or times, yep.
5 times the number.
Any questions before we take a look at our last problem? All right. Our last problem.
Guys, on that back side where it says 1.1 part 2, you don't have, guys, don't write the whole, you don't have to write the whole word problem.
Yeah, there's only two things
Yeah,
that
just
are
write,
important.
just write whatever Mr. Hager writes, we want you guys to write. Because there's one very similar to this on the homework tonight. Would rather be in 2012 Olympics. It was just this past Olympics, 2016. And he won again.
So this problem is, it's in your book. Okay, it says in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write an equation to find his average speed. All right? So obviously, he's not going the same speed the whole time, because think about when you start, you're stopped. So then you build up speed until you hit your fastest speed. All right? But there's an average speed he traveled. And that's what we're going to figure out. So there's a formula that involves rate, distance, and time. Does anybody know what that formula is? It involves an R, a T, and a D. If you don't know it, that's okay.
Doesn't it start with D equals?
Yep. Do you know it, Shannon?
D equals RT.
Yeah. Okay, so that is a very important formula. We'll see it a few different times this year. Okay, D equals RT. D is a distance. R is a rate, or sometimes we call it how fast. It's a speed. And T stands for time. Now I'm going to look through this problem, and I'm going to see if I can find some numbers here and maybe a place in this formula I can plug them in. 200 meter. What do you think that is in this formula? Yeah, 200 meters. That's a distance. 19.32 seconds. That's a time, right? Just squeeze a T in there. And they're asking me to write an equation to find speed. Okay. What letter is speed? That's R. So can anyone tell me what this equation is going to look like once I fill in the two numbers that I have? Shannon?
200 equals R times 19.32.
200 equals R. I'm going to use a parenthesis because I think the decimal might look confusing. I use a dot for multiplication. But what Shannon said is perfect. 200 equals R times 19.32. Now my goal
Can I
is,
just have everyone's attention?
okay, so as I was saying, my goal here is to get R by itself. So using something we learned today, who can tell me how I get this 19.32 on the other side? Okay, how about Sabrina? Yeah. And what did you say, divide by? Perfect. I'm going to divide each side by 19.32. On the right-hand side, all that leaves me with is R. On the left, I definitely need my calculator. And that's a speed of 10 point, let's round it to two places, 10.35. Now, what was the distance measured in? Was it miles or meters per? And what was the time measured in? Was it days, hours, seconds? So he was running at 10.35 meters per second. Okay, if you converted that to feet, he's moving pretty fast. That's almost like running 30 feet a second. It's pretty fast. All right, so Mr. Roy is passing out your homework tonight. Don't forget test on Friday, and try to get a binder for tomorrow, Thursday, binder for Thursday.